everybody, how are you? So you're doing very well. Today inshallah we'll talk about the life cycle of stars, or third lesson in this unit. So dear students, you might remember that so far we have learned about what? We have learned about star, the major component of star, and what else? The main properties of stars, such as brightness, luminosity, temperature, their colors, and how to measure each of these properties, how to measure the brightness of a star, the scale that we use to measure the luminosity of star, how to measure temperature, and so on. Today inshallah we'll talk in more details about the life cycle of a star. So guys, as we know, sky is full of stars that are at different stages in their life cycles. Okay, so actually a star begins life within a cloud of gas and dust. This cloud is called what? It's called a nebula. So stars actually form in nebula, as you can see here in this photo. And what is a nebula? A nebula is a large cloud of gas and dust. Then a large cloud of gas and dust. So this nebula actually is composed mainly of which kind of gases, guys? It's composed mainly of hydrogen and helium gases, in addition to small amounts of other heavier elements. And guys, you may remember that we said that in our previous lesson that stars composed mainly of what? Of gases such as hydrogen and helium. So it's the same for nebula, as stars will form in this cloud. Okay, so now you may know why stars contain helium and hydrogen, because the place from which in which they form actually contains a large amount of these gases, which is the nebula. Okay, so again, nebula is a large cloud of gas and dust, and mainly it's composed of hydrogen and helium gas. Okay, that's why stars contains mostly hydrogen and helium. So now guys, as you can see here, this cloud is actually this loose cloud. How it will change to give us the dense stars? Actually guys, scientists believe that an outside force, such as explosion of a nearby star, may cause these loose nebula to contract and cool. Okay, so an explosion in certain area here in the universe nearby this nebula, okay, cause this nebula to contract and cool. Okay, so what will happen next, guys? As particles within the nebula are pulled closer together, gravitational attraction increase. So this loose area, as we said, will contract, and all the elements inside and the particles inside this nebula will be pulled closer together. The gravitational attraction within and between these particles will increase, which will cause this loose area to form a more denser area. Okay, so the dense region, or the dense region of gas and dust that will form within the nebula because of as we said, because of the explosion of the nearby stars, this dense area, guys, called what? Called dense cores. The dense cores here will form what? Form new stars. So actually guys, again, stars, as we said, is a dense body, but it come and it formed what? It forms actually from a loose area of clouds and gas. This area is called nebula. Again, as we said, explosion in one of the stars or number of stars around this area will what? will cause this loose area to what? To condense, okay, and to change into a dense core. This dense core actually will form the beginning of what? Of the star formation, okay. So guys, as you can see here in this photo, this is the nebula, and as we can see here, this area are much looser than the one in the center. Here the bright regions within this nebula are areas of greater density. So here at the core we have the greater what? Density, okay, that will form, as we said, because after certain explosion happens in the nearby stars, the particles inside this nebula will start to what? Will start to contract, and they will pull toward each other to form a denser area here in the center. The dense area is called what? This dense area is called the core, and this core is the place at which stars start to form, okay. So the question here is, what is happening in the circled part of this nebula? Guys, again, what do you think is happening here in the core of this nebula? Yes, exactly, new star is forming at the core of this nebula, okay. So again guys, the core of the nebula, which is the denser area, is the place at which stars form. So guys, you may remember that we said that the two main properties of stars, that these stars actually are contain mostly hydrogen and helium gases, and they also emit light, they emit energy. So now we will know this energy that these stars are producing will come from where. Actually, what is the source of this energy? Okay, actually the source of this energy is kind of reaction called nuclear fusion, and this nuclear fusion will emit a huge amount of energy from these stars. So like the temperature within dense cores increases for millions of years. At about 10 million degrees Celsius, the process of hydrogen nuclear fusion begins, marking the birth of a star. So once the temperature within the dense core reaches 10 million degrees Celsius, the process of nuclear fusion or hydrogen in nuclear fusion begins, and once this process begins, means that stars start to form and appear, okay. So a star can remain actively fusing hydrogen into helium for billions of years. This stage ends when the star runs out of hydrogen. As we said, stars form in a nebula, and in each nebula there is a certain amount of hydrogen gases. So when the star runs out of hydrogen, then there will be no more hydrogen nuclear fusion, okay. So guys, as we said, the hot stars or the hot dense cores will trigger a process called nuclear fusion to happen. So what is a nuclear fusion, guys? A nuclear fusion is a kind of reaction that will affect the nucleus of certain element, and as we know, each atom contains in the center something called the nucleus, and this nucleus contains protons and the neutrons, okay. So guys, usually nuclear fusion happens in 3 steps. As we can see here, guys, here we have 2 atoms of an element called hydrogen, and each element here, as I said, at the center we have a nucleus, and this nucleus contains one proton, okay. So H1 and H1, so a nucleus of 2 hydrogen atoms will fuse together, okay. when they fuse, as we can see here, a certain amount of energy will be emitted, and at the end it will result in the formation of a new hydrogen atom. But this time in this hydrogen atom we have 2 protons instead of 1 proton. Okay, so again, the first step, 2 hydrogen atoms, each contains 1 proton, will fuse together and result in the formation of a hydrogen atom that contains 2 protons. Okay, then again, the newly formed hydrogen atom, the one that contains 2 protons, will fuse with another hydrogen proton, the normal one that contains 1 hydrogen or 1 proton. So hydrogen 1 with hydrogen 2, these 2 nucleus will fuse together and result in what? In the formation of a new element, a totally new element called what? Helium. And this helium contain what? Contain 3 protons. Okay, so again guys, in this step, 1 hydrogen atom will fuse with 1 hydrogen atom, and this hydrogen atom contains 2 protons. Okay, so these 2 hydrogen atoms will fuse to give us an element called helium. This helium contains what? As we can see here, contains it's a nucleus, actually contains 3 protons. Okay, so in the third step guys, what will happen? Here we have the helium that formed in this step. Okay, this helium will fuse with another helium atom, helium 3, with helium 3. Okay, and this process guys will result in what? Will result in the release of amount of energy. It will release also, as you can see here, several atoms. We have hydrogen 1 and hydrogen 1, 2 hydrogen 1 atom, and 1 helium atom with 4 protons. Okay, so guys, the question here, look at the start of the first reaction, this photo. Compare this to the end of the last reaction, so the beginning of the reaction and the last reaction. What type of nuclei are found at both ends of the reaction? So guys, in this image we have 2 hydrogen atoms, or 2 hydrogen nuclei, each contain 1 proton. Okay, and on the other side we have what? Hydrogen atom that contain 2 protons. Okay, this is for the first reaction. What about guys the last reaction? The last reaction, at this side we have 2 helium nuclei, each contains 3 protons. On the other side of the reaction we have 2 hydrogen nuclei, each contains 1 proton, in addition to 1 helium nuclei contains 4 protons. So guys, again, this diagram summarizes the 3 steps of nuclear fusion that will result in the production of the energy that stars usually emit. Okay, so again guys, the energy that is produced by the stars, okay, actually comes from what? Comes from a process called the nuclear fusion. And in nuclear fusion, as I said, atoms of hydrogen will fuse to form what? A new atoms. During the fusing of these atoms of these nuclei, an amount of energy will be emitted. Okay, so dear students, here we have 2 questions from the lesson review. Question number 5 says, what force causes star to form form a nebula. As we said, stars form from loose area of dust and gases. This area is called what? Nebula. And this loose nebula is the place where stars or the dense stars will form. Okay, and we say that there's something that will cause this loose area to contract and form a dense core, which is where stars form. What is kind of or what is the name of this force that will cause this contraction, guys? Remember? Yes, exactly, it's the gravitational force, or simply gravity. Okay, so the answer here would be simply gravity. Okay, so here's the answer. What about question number 6? Explain what triggers nuclear fusion in stars. You remember, guys, what triggers nuclear fusion in stars? Yeah, so actually, as we said, fusion reaction or nuclear fusion is triggered when the temperature within the center of the core of hot, dense, contracting gas and dust reaches a high enough temperature, and was maybe about 10 million degrees Celsius. So the hot temperature, this very high temperature, will trigger what? The nuclear fusion process to start. Okay, so guys, here's the answer. Fusion is triggered when the temperature within the center of the core of hot, dense, contracting gas and dust reaches a high enough temperature. Okay, so guys, that's all for today. Thank you, and see you inshallah tomorrow.